Good afternoon. First of all, I got to say that's a great honor to be here today among you guys, to be part of this historic international conference in memory of Richard Leakey. As I was sitting there listening to Bernard, I was like, wow, there's a lot of stuff that I didn't know. As a paleoanthropologist, I should have known most of it or read about it, but there were lots of new things that I heard from Bernard. The first time I heard the name Richard Leakey was when I was an undergraduate student, undergraduate student in history. And I had an archaeology teacher by the name Richard Wilding. So he used to go to Kenya to do some field research, and he comes back to teach. And that was the first time that I heard the name Richard Leakey, and also Australopithecus. So, but since then, through grad school, I came to know more about Richard and his work in Kenya. So when I chose this title for this conference, Mid-Pliocene Hominid Diversity, it just reminded me of the controversies around hominid diversity in the 1970s, which Bernard mentioned a little bit about. The discovery of KNBR 406 and the Homo cranium that you saw on Bernard's slide literally falsified a hypothesis that's been there, like the single species hypothesis. Now, almost 50 years later, we're still talking about hominid diversity, even though it's a different time period, right? We're talking about a little earlier time, mid-Pliocene, and trying to debate whether there was diversity during the mid-Pliocene time period. So when I thought about the title, I said, well, there is something that I can refer to, like work by Richard Leakey, like in the 1970s. Secondly, I also thought, well, the theme of this conference is Africa, the human cradle. And as a paleoanthropologist born in Ethiopia, I felt obliged to tell you, like, what is the contribution of Ethiopia in making Africa the human cradle? So when I came here, I had those two things in mind. And, but first, when you think about Africa as the cradle of humanity or the human cradle, there's a very long history. It's not a 50 years history, but it's 100 years history. Because it goes back to 1924 with the discovery of the tongue baby from South Africa. That is what started people's attention toward Africa as the country of the continent of human origins. 1930s, 40s, all the work that has been going on in South Africa, all the fossils were really marvelous. But then in the 1950s, as you know, with the discovery of zinc in 1959 by Louis and Mary Leakey, the attention became like more toward Eastern Africa, right? And all the work that has been going on in the 60s was really what added to that record. So when you look at all the sites that we have today, sites with fossil discoveries that make Africa the human cradle. You start from South Africa, you go all the way across the East African Rift System to Ethiopia. All these little red dots that you see have provided with fossil evidence to tell us about human origins. And they cover almost the last 6 million years of our evolutionary history. So it's really an interesting subject that we've been following, and there are lots of questions that we try to answer, and this mid-Pliocene hominid diversity is one of the current questions that we have to debate. So when we say Africa is the human cradle, just to show you the record from Ethiopia, Kenya, and South Africa, we have pretty much the last 6 million years sampled from the Ethiopian fossil record. The same is true for Kenya because of all the work by Richard and his colleagues in the last almost 50 years. And it's really interesting to have Bernard talk about it because this is a history told by a person who was part of that history. And as a history student, I really appreciate that. And I've learned a lot from his talk today. But again, in South Africa, where it all started in the 1920s, we have good record from South Africa. So when you combine all of this record, is when you realize that we have Africa as the human cradle. Now, what is the contribution of Ethiopia to all of this, right? And this is what I'm going to tell you a little bit about, because there's also a history here that connects to Richard Leakey, okay? This is when, and also mentioned by Bernard a little bit, the history of paleoanthropology in Ethiopia starts with the work in the Omo Basin, right? And the Omo Basin, even though most of the hominin fossils that we know today from Ethiopia are known from the Afar Rift, we have about 5 of them known from the Omo Basin. Now, when they went in 1967, the team, the Kenyan contingent led by Richard Leakey, was the one who found the first hominins from there, Omo 1 and Omo 2, and you saw one of the slides, right? And they were published in Nature in 1969. So that kind of marked the beginning of the great interest that have been developing since the late 1950s, I believe, when Clark Howe actually went to the Omo in 1959. And Lewis has also sent people to investigate Omo Basin before that. So that combined effort between Louis Leakey and Clark Howe is what established the International Omo Research Expedition in 1967. So when they went there, of course, they found Omo 1 and Omo 2. But I also think that it was not just about Omo 1 and Omo 2 for Richard, because that flight back from Nairobi to the Omo Basin was really critical, because that's when they flew across the Kumbifora deposits when they were going back to the Omo. And that diversion of National Geographic Society's fund that was mentioned earlier was because of that. Richard wanted to do research in the Kumbifora area. And we have all these fabulous discoveries from that site. So Ethiopia's role in general is what you're seeing here, so many species found. But of course, early 1970s, interest developed in the Afar region. And that's when, in 1972, they formed the International Afar Research Expedition, some of whom were members of the Omo Research Expedition, including Yves Coppens. Donald Johansen was also part of that, and they moved to the Afar and started finding so many fossils there. And specifically, the discovery of this young lady, Lucy, kind of diverted the whole attention from the Omo Basin to Harar. And today we have like 7 or 8 projects working, conducting field research in the Afar region of Ethiopia. And today I am one of them. I was trained as a paleoanthropologist, and I have my own field research in this part of Africa, in the Afar Rift. And looking at the record that has come from Ethiopia, it's just a glimpse of what has been discovered in the Afar Rift and also in the Omo Basin. And practically, you can see that it covers almost the last 6 million years of our evolutionary history. So this is what adds to the discoveries from Kenya, the discoveries from Tanzania, the discoveries from South Africa. It is the combination of all of these discoveries that makes Africa the human cradle. But the contribution that you see from Ethiopia is also really significant, and that's why we have so many projects doing research in Ethiopia. So I started working on my own project in 2005 after 3 years of survey and exploration in the northern part of the Afar Rift, because I couldn't do any research in the areas that have already been taken. Middle Awash, Harar, Gona, they're all occupied by other researchers, so I had to do survey and exploration further to the north, and that's how we found Woranso-Mille. And we found really significant fossil specimens from there. And some of them, as I will explain a little bit later, controversial in terms of species recognition, what they belong to, and so forth. But this is, again, a result of continued survey and exploration that we have known is really great from our predecessors, right? This is a new generation of paleoanthropologists that we're talking about. They have to go out, survey and explore, do field research and find new sites, because there are still a lot of areas that haven't been investigated. So there is a lot of potential for future paleoanthropologists from Africa and elsewhere. So this was one of the occasions when you do research and you end up finding a really, really, really good site like Woranso-Mille. Now, Woranso-Mille so far has yielded a number of species, which includes like Australopithecus anamensis and Australopithecus afarensis. And as you will see later, new species that we named in 2015, Australopithecus deiremida. But of course, for all of this, we had to really work on the geology, stratigraphy, and figure out how old these fossils are. And that's what we did. And that's also what they did in the 1960s with the Omo. They did not start finding fossils first. They sent Frank Brown to do the geology, 1965, right? So he did all the geology, and that's because stratigraphy, understanding the age of these fossils that we're finding, is really significant. So when we find a new site like Woranso-Mille, the first thing that we had to do was really understand what the stratigraphy is, what the age of these different horizons are, and so forth. And that's what we did with our geology. So we have pretty much good understanding of the stratigraphy of most of the localities at Woranso-Mille. And what you're seeing on the right side is a composite of the whole site that samples the last 800,000 years to 1 million years. So when we talk about mid-Pliocene hominin diversity, I'm going to specifically talk about the time between 3.5 and 3.3, 3.2 million years ago. But from Woranso-Mille, we have really significant specimens that are older than 3.6 and younger than 3.9. And this is, again, a very significant time period that's not sampled in a lot of other places. So that's one of the most significant points that I can raise about Woranso-Mille. It samples a time period that we don't have much from other sites in Kenya, Tanzania, or South Africa. So these are some of the specimens that we have from deposits that are dated to between 3.6 and 3.8 million years ago, including the first cranium of Australopithecus anamensis, whose holotype and also type locality is in Kenya. We have a partial skeleton that we nicknamed Kadanumu from about 3.6 billion years ago. Again, this was really significant specimen because of what it's preserved, especially the complete scapula that you're seeing on the screen, and also the rib fragments that we had, which kind of allowed us to better reconstruct the rib cage of Australopithecus afarensis. But most importantly, what do we have from Woranso-Mille from the time between 3.3 to 3.5 million years ago? That's really what I'm interested in, particularly in relation to hominin diversity during the mid-Pliocene. Now, Australopithecus anamensis is well known from Ethiopia, from Kenya. Australopithecus afarensis has been known since the 1970s, and nobody really doubts that afarensis is a valid species. But Australopithecus deiremida is a relatively new species that we named based on discoveries from Woranso-Mille. And I can tell you that some of my colleagues don't think that it's a valid species. Now, what do we do to convince our colleagues that this is really a valid species? Because the sample size that we have for the species is so limited right now, hence the doubt, we have to go back to the field, do more research, find more fossils, and see if this is actually a valid species. And that's what we're going to do in the next however many years that we do field research. The other one is the Burtelle foot. This was found in 2012 that you see on the very right end. Well, a lot of my colleagues don't think that this foot belongs to Australopithecus afarensis because it's very different in terms of what you can infer in terms of its locomotor adaptation. This is not a bipedal, human-like or afarensis-like bipedal creature that we're looking at. So at least that kind of gives you a hint that there was yet a second species that lived contemporaneously with Australopithecus afarensis at that time. So having said that, the first thing that we have to do is, are these really additions to the fossil record that we have, right? So Australopithecus deiremida, why is it a new species? For us, we look at some of the morphological features of what is preserved in these specimens. We have a couple more additional specimens assigned to Australopithecus deiremida, but most of what we used as a diagnostic features of the species come from the maxilla and also the mandible that you're seeing here. So we came up with a few traits that actually we thought would distinguish it from Australopithecus afarensis, and we named this new species Australopithecus deiremida. And as I said, I am convinced that this is a different species, but some colleagues don't think it's a valid species, and that's why we have to really increase the sample size and test our hypothesis whether this is a new species or not. But what's really interesting is the Burtelle foot comes from a locality where we have Australopithecus deiremida. Now, a lot of my colleagues have asked me, why didn't you put it into Australopithecus deiramida, which would have made that species really, acceptable for people. But the problem is we didn't see any clear association between the foot and the craniodental specimens that you saw. So what that means is that we have to really find something associated with that foot and see if those associated craniodental specimens are actually similar to what we have identified as Australopithecus deiramida. So that's the next step of our research. But obviously, this tells you that we have something that is different from Australopithecus afarensis. What that means is we have at least two species living at the same time. This is something that Richard showed convincingly in the 1970s with Boisei and Homo to have lived at the same time in the same area. So now we're trying to show that with conclusive evidence that diversity actually happened even much earlier in the mid-Pliocene time. But that needs to recover more fossils from sites in Ethiopia and also elsewhere, where we have species that also lived at the same time as Australopithecus afarensis. One is Kenyanthropus platyops, which is from Kenya. That species also lived somewhere between 3.3 and 3.5 million years ago. Is it a valid species? Some people doubt that it's not. Some others convincingly argue that it is a valid species. Some others think that it may be part of the Australopithecus hypotype and not a new genus. So those are the kinds of debates that we have in our field. But for us, especially based on the discoveries from Woranso-Mille, we can say that the Burtele foot in no way would have made those footprints that were recovered from Maitoli from about 3.6 million years ago. So that is as convincing as it is that there is a species other than Australopithecus afarensis that lived side by side in the Woranso-Mille area, which is in the Afar region of Ethiopia. But interestingly enough, this partial foot, the 3.4 million year old partial foot, has some similarities to another species 1 million years older, from 4.4 million years ago, found in the Middle Awash, known as Ardipithecus ramidus. Is this like a relict species of that genus, or is it something that is different from Ardipithecus? That remains to be seen with more fossil discoveries from Woranso-Mille. So with all those fossils in hand, we ask questions, right? So the first question is, was there really hominin diversity during the mid-Pliocene? Second question would be, is Australopithecus deiramida different from Australopithecus afarensis? And finally, is the Burtele foot different from the foot of Australopithecus afarensis? That we may already have the answer. Yes, it is. But for the first ones, you need more fossils to really test those hypotheses. But at the same time, when we talk about diversity and contemporaneity, we have to really think about the time. How old are these specimens or these species? And I want to show you their temporal distribution so that you can see where they are in terms of their temporal distribution. For Australopithecus afarensis, we have remains of Australopithecus afarensis from 3.6 all the way to 3.2 million years ago. Then for Australopithecus deiramida, we have that time period which overlaps with Australopithecus afarensis between 3.3 and 3.5 million years ago. And the Burtele foot is right in between. It's right there, right? So this is the evidence that we're talking about that's coming out from Woranso-Mille. And I think if the Australopithecus deiramida as a species is not convincing, then the Burtele foot is. So we have at least two different species from that time period. And this is really important because it tells us not only about how many species existed at the same time, but also how are they related? How did they manage to coexist in the same area at the same time? But of course, the Burtele foot remains to be different from what we have. So when we talk about overlap, in this case, it's also geographic, like Boisei and Homo in the Turkana Basin. So what you're seeing here is like the geographic location of what we have identified as Australopithecus afarensis, Australopithecus deiramida, and the Burtele foot. They're in the same area. And if you go down about 30 miles is where you find Harar, where you have just one species, Australopithecus afarensis. So that geographic distance between Harar and Woranso-Mille is not much. 30 miles for populations of hominin or other animal to move, that's very easy. But why don't we see such diversity at Harar? This is what brings questions related to understanding the habitat, the environment, the topography of where we're finding all these animals, right? And that's what we're doing now, to understand why do we have diversity in Woranso-Mille and not at nearby Harar. So diversity has always been there. I don't think any of us would actually argue that there was no diversity in our evolutionary history at any given time, because that has been shown in the past with good fossil evidence. We're seeing some evidence now for the presence of diversity even during Middle Pliocene, and it would be surprising if we saw more diversity even much earlier, right? It's all about what are we finding in the fossil record and how do we understand those fossil discoveries. So this is one of my favorite photos, and as Bernard said, whoever looks at these two images, these two skulls, there's no way you can mistake those to be of the same species, right? So what we need is a very strong evidence like this to actually show that there was diversity even much earlier during the Middle Pliocene. And I'm telling you, I'm trying my best to find something like that. So diversity is very common, and this is what we see today, unlike what was there at that time in the 1970s. You saw this one in a different form on Bernard's talk, but we have so many species. And what you're seeing here is there was probably a diversity during the Middle Pliocene. The question is how many of these are actually valid species and how many aren't? That's one of the controversial issues that we as paleoanthropologists are trying to deal with today. So question number one for me as a paleoanthropologist is how did they manage to coexist in the same area at the same time, at Woranso-Mille, and not at the nearby Harar site where there is only one species? This is really an important question because it relates to not only to this time period, but also to other time periods even before this, if we have evidence to show that there were multiple hominid species. The other question is, which one of these mid-Pliocene hominins is the ancestor of the genus Homo, right? That's a very interesting question because if you go back I would say 20 years, there was only one candidate, which is Australopithecus afarensis. Now with the appearance of a lot more hominid species overlapping in time and space with Australopithecus afarensis, the question is open. Any one of these, maybe except for the last one, could be the ancestor of the genus Homo. And now you look at the age written underneath each of those. Well, afarensis existed until about 2.95. The earliest evidence that we have for the genus Homo is at 2.8 from Lady Gararo in the Afar region of Ethiopia. So obviously you would argue that that's probably the ancestor because the other ones lived much earlier. But the problem is the fossil record is not always complete, right? So you see those Australopithecus deiramida 3.5 to 3.3, Kenanthropus platyops 3.5 to 3.33, but we don't really know when they started or when they ended. So in other words, we don't know their first appearance date or last appearance date. It's just all about what we find when we go out to the field. And it wouldn't be a surprise if we found Kenanthropus platyops from 3 million years or Australopithecus deiramida from 3 million years. It's just we have to go back and find more fossils to test our hypothesis that we propose. So obviously, this is a code that I took from the Turkana Basin website. And I find it really interesting. This is what we do. This is about science. This is about going out, finding more fossils, testing your hypotheses, and try to get as close to the reality as possible, right? So everything that we talk about our evolutionary history is a lot of times hypothetical to be tested based on the fossil that we find in the fossil record. So Africa is indeed the human cradle. We all agree because we see the fossil evidence. There's no doubt about that. But there is one thing that's really lacking, and that's not going hand in hand with this. And that is the African paleoanthropological infrastructure. It is not really catching up with all these fossils that we're finding, right? So how do we leverage all these wonderful fossil discoveries to develop African paleoanthropological infrastructure. That's something that we have to really think about. We see a lot of progress in the last 2 or 3 decades, but that's not enough. Why can't we do all the research that we're doing elsewhere in Africa? We know why. And if we can help or think about it, like in terms of how we can make this happen in the future, is something that I would actually suggest in this talk. And we've seen so many paleoanthropologists, great paleoanthropologists who've left their legacy, like Richard, right? Some of these legacies are really, they endure like long time, and they're really exceptional legacies. And Richard is probably one of those with an exceptional legacy. And I say that because of the Turkana Basin Institute. This is one thing that you can do to change the current situation. How do we support African paleoanthropology? How do we support the infrastructure? And this is also from the Turkana Basin website, the opportunity to facilitate new explorers' discovery of the treasures buried in the Turkana Basin has been my dream. We should have this as our dream too. Why don't we have the Omo Basin Institute? Why don't we have the Afar Rift Institute? Why don't we have the Oldupai Gorge Institute? Why don't we have the Sterkfontein Institute? It's doable, but we have to come together to actually make this happen. But this is exemplary in terms of what Richard has done with the Turkana Basin Institute. It's something that we have to think about doing in all of these other countries with a lot of treasure, fossil treasure, that we're using to better understand our evolutionary history. And as a matter of fact, 2024 marks the 50th anniversary of Lucy's discovery. And at the Institute of Human Origins, we're organizing a symposium to talk about Lucy's impact, not only in science, but also on the development of African paleoanthropological infrastructure. So this is a symposium that my colleague Curtis Marion, who's in the audience, and myself are trying to organize to actually talk about how can we make a difference, right? And that symposium, maybe half-day workshop on this issue, is going to be like the beginning of further discussions to have like multi-day workshops with all stakeholders being part of it. And this is something that you might be interested in. If you are, you can either get in touch with me or with Curtis, and we can give you all of the information in terms of what this workshop is going to be about. So with that, thank you so much for your attention, and really great to be here. And I appreciate, Fred, your introduction was great. Thank you.